So last time we were here. Okay, so we tried to learn advanced algorithms for sorting and searching arrays. The selection sort works by allocating the smallest value and moving it to the element 0. Then finding the second smallest value and moving it to element 1. And then continuing the process until all the elements have been placed in their proper order. Basically, with this sorting algorithm, we want to sort, okay, a numeric array. So we can sort it from the smallest one to the largest one, okay? So you see that here we define a function which is swap. So you see swap here, we start with a capital letter because for naming convention of methods, we follow the Pascal convention, okay? All words will start with a capital letter. Also because for this swap method, so we would like to basically exchange the two different arguments. So we would like to operate on the original variable, not operate on the copy, right? You see that I have mentioned this last time. So if we don't use reference, okay, we don't use reference, so we are going to get a copy, right? Then all the statements will be based on the copy. It means if we change the value, so the copy will be changed. Nothing will happen to the original variable. That is a thing. So in order to change the original variable in the method, we need what? We need to use reference, okay, reference, which is this. That's why we use ref. Ref int a and ref int b, okay? You see that int. We have temp equals a equals b equals temp. So basically we have two bottles, A and B. We have a third bottle temp, right? We first put the water in bottle A in the temp. Then we put the wine in bottle B in bottle A. We put the water in temp in bottle B. Basically, we exchange, right, the liquid in the two different bottles, A and B. Because we use ref, so when the method is executed, so the two variables, the value of the two variables will be exchanged. That is the logic of the method swap. So here is a sorting and searching arrays, okay? Sorting and searching arrays. So last time, so we try to follow this algorithm, okay? By using this example, we try to follow this algorithm by using this example, okay? So today we are going we will continue with this detailed analysis to see how it works, okay, how it works. So this is what we have last time. So let's close this. Okay. Yeah, that is it. Okay. We will go to this algorithm and we put our notes on the left. Okay. So this is what we had last time, and we have analyzed this, right? Let's start from the beginning to make it clear. Okay, to make it clear, right? So we have 67, 98, 45, 23, 88. By the way, I need to emphasize it again. So these algorithms are the most challenging materials in this whole semester, okay? So in the future, when you start to learn advanced programming courses like Java programming, data structure, or data analytics algorithm, data mining, machine learning, So you will learn a lot of algorithms, okay? So when you want to build your code, so these algorithms are important. So when you want to use some packages, these algorithms are still useful. Why? Because so you will use each package as one statement. You do not need to build each package from scratch. However, in order to accomplish some data analytics objective, you still need to write some high-level algorithms by using these packages, okay? This is why learning algorithms is always useful, always useful. So let's start from what we had last time. So we have two different iterations. The first iteration, we call it out iteration. You see, this is the out loop, right? Out loop, this for. So we also have a second, right, iteration, which is the inner loop. Okay, this is a inner for. We have outer loop and inner loop, okay? So we are going to analyze the algorithm based on the outer loop. Okay, you see, for outer iteration number 1, so we have start scan. It is initial condition 0. It is given here. So array I array length. So we have an array with 5 elements. So the length equals 5. So 0 is less than 5. The condition is true here. So, sorry, length minus 1, it is 4, okay, it is 4. So we have mean index is start scan, okay, start scan 0, mean index 0. So mean value is I array start scan, which is the first element of the array, which is 67, okay. Then we move on to the inner loop. So for the inner loop, index equals start scan plus 1, 0 plus 1 is 1. So index is less than I array length index, which is 0 plus 1 is 1 less than 5. Okay, so the condition is true for this inner loop. Index is 1. So we have if I array index number 1 is the second element, which is 98, right? 98 in the array. If I array 1, 98 less than mean value. So mean value in the out iteration, mean value has been set to 67. Which is the first element in the array. So 98 is less than 67, that the condition is false, okay? So we don't need to go inside this if structure. We go to the next loop, in the loop. So index plus plus, index equals 2. So we would like to check if I array index number 2, which is the third element, okay, less than mean value. Third element is 45. 45 is less than 67. So that condition is true, okay? So we got mean value, we update mean value, which is 45, mean index, which is number 2. So in this case, and we move on to the next one. So index, the third inner iteration, index equals number 3. So 23, which is the fourth element, okay, fourth element in the array. So 23 is less than mean value, 45. That expression is also true. So mean value equals 23, mean index is 3, because we go inside the if structure. So when we are done, we go back and update index. Index equals number 4. 4 is less than 5, so the expression is true. So we go inside the for loop, in the loop. So the fifth element for I array is 88. So 88 is less than mean value 23. That expression is false. Okay, it is false. So we will skip the whole if structure. Then we can see that mean value is 23. Mean index is 3, right? So you see that now we have mean index is 3. So mean value is 23. So we go this swap method, which is, so we are going to do what? I array mean index. Remember, in the first outer loop, mean index is what? Mean index has been updated to 3, right? It is 3. Start scan, it is still 0 because we are still in the first outer iteration. So we are going to swap index number 0 and index number 3, which is we are going to swap the first element and the fourth element. So we are going to swap what? The first element and the fourth element. Okay, the fourth element. So basically we got what? 23, 98, 45, 67, and 88. Okay, 88. You see, this is so the output, right? The output of the array when we finish the first out loop iteration. Okay, so today you will have a quiz problem. I will give you a different array, and I will ask you to find the output of the array after each outer iteration. For example, in this example, after the first outer iteration, so the output of the array will be 23, 98, 45, 67, and 88. Okay, so we can continue with this process. So I can try to copy what I have here, right? I have here. So I don't want to type it again to finish the other iterations. Okay. So for outer iteration number 2, okay. So start scan will be start scan plus plus. So in the first outer iteration, it is 0. Now it is 1. Okay. So min index equals start scan, which is also number 1. So min value is I array start scan, which is the second element in the new array, right? We have updated the original array to what? 23, 98, 45, 67, and 88. So min value, which is start scan number 1, is the second element of the updated array. So min value will be the second element, right? Second element in the array, and it is 98. Okay, it is 98. Then we go to the inner loop. So index will start from what? We'll start from start scan plus 1, which is 1 plus 1, and it is 2. Okay. In the first inner iteration, index equals 2. So we would like to check this if condition I array index number 2, which is the third element in the updated array. So for the third element in the updated array, it is 45. It is 45. So min value, it has been set to 98, right? In the beginning of the second outer iteration, so it is 98. Okay, 45 is less than 98. That expression is true. Okay, it is true. So we are going to update, go inside the if, right? Go inside the if structure. So we can update, right? We can update. So min value is I array index, which is 45. Min index, it is what? It is, so, sorry, this is number 2, okay? So min index is number 2, okay? It is number 2. So now we finish the if structure, we move on to the next iteration, index plus plus, index equals 3, okay? So I array 3, which is the fourth element in the updated array, which is 67. So 67 less than min value, which is 45. So that expression is false, okay? So we will not update min value, and we will not update min index, okay? We move on to inner iteration number 3. So for inner iteration number 3, index equals 4, okay? So for index equals 4, which is the last element in the updated array, and it is 88, okay? It is 88. 88, so min value is 45, 88 is less than 45. So that expression, it is false, okay? So there is no update, right? For both min value and so min index, okay? So we have reached the end of the array, the last element, the fifth element. So there is no more inner iteration, right? There is no more inner iteration. Index equals 5, no more inner iteration. So we have, so mean value is 45. Mean index is number 2, okay? So we are going to swap what? Swap. So start scan is number 1, mean index is number 2. Basically, number 1 is a second element, number 2 is a third element. We are going to swap the second element and the third element in the updated array, okay? Updated array. So we are going to update what? Update. So number 1, index number 1, and index number 2, okay? So basically it is a second element and the third element. So after that, we can see that after the second out iteration, the array will be what? It will be, we are going to swap 98 and 45. 45 here, 98 there, okay? Then we can move on to the third out iteration. So which is, let me copy this here. So we have iteration number 3. So start scan will be plus plus, it is number 2. Mean index equals start scan, also number 2. Mean value, it is array number 2, which is the third element in the new array, right? Update array. The third element is still 98. 98. So for inner loop, inner iteration, start scan plus 1, it is 3. So the 3 is the fourth element in the array, which is 67. Okay, 67. So mean value is 98, which is true. So mean value, we'll update mean value as 67, and mean index is index, which is 3. Okay, which is 3. Inner iteration number 2. So we are going to update. So sorry. Index is number 4, yeah. So we have, let me see if that is correct. 2, 3. Sorry, this is 3, okay. Fourth element, it is 3. So we update mean index to be number 4. The last element will be 88. Okay, it will be 88. So mean value, it is 67. You have to be very clear about each step, because I give you all these steps because when you debug your own code in the future, when you work on a big project, so these steps are key, because you will run the code by yourself and compare results from your analysis with the results from the C#, right? So if both results match to each other, then it means at least this part is correct. Otherwise, if there is a mismatch, it implies that something is wrong. Something is wrong. So that is how we fix errors, logic errors, in the code. Okay, in the code. So in the iteration number 2, index is 4. So last element in the updated array is 88. So 88 is less than 67. It is false. Okay, it is false. So we have reached the end of the array. There is no more inner iteration. Okay, so we got mean value is 67, mean index is 3. So start scan is 2, mean index is 3, right? So we are going to swap. So the number 2 third element and the fourth element, which means, so we are going to swap 98 and 67. Okay, third element and the fourth element. So after third out iteration, array will be 67, 98, and 88. Okay, then we have one more iteration to go. So for the last iteration, so for iteration number what? Number 4. Okay, number 4. So start scan plus plus. So we start scan in the previous one, it is 2, right? So start scan, it is 3. Mean index is 3. Mean value is array index number 3, fourth element. It is 98. Okay, for inner loop. So inner iteration index equals. So index equals start scan plus 1. So it is number 4. So I array number 4, it is the last element, which is 88. Okay. So 88 less than mean value 98, it is true. So mean value is 88. So mean index, it is 4. Okay, number 4. So we have reached the end of the array index. When we update the index to number 5, there will be no more inner iterations. Okay, so we have inner value equals 88, mean index equals 4. Okay, so now we are going to swap start scan 3, and mean index 4, which is the last two elements, 98 and 88. Okay, so we are going to update swap 98 and 88. So we have so we finish, right? Do we finish? So you see start scan now equals what? It equals 3 when we are done with the swap method. Start scan equals plus, which will give us number 4, right? Length is 5. 5 minus 1 is 4. 4 less than 4, the condition for the outer expression, that condition is false. So we are done with all the outer iterations. There will be no more outer iterations, okay? There will be no more outer iterations. So you see that we finish, in total we have 4 different outer iterations, right? So one interesting observation is what it is. So in the first outer iteration, you see we have 1, 2, 3, 4 different inner iterations. So in the second outer iterations, we have 1, 2, 3, right? Inner iterations. In the third outer iterations, we have 1, 2, right? Only 2. In the last outer iteration, we have only 1 inner iteration. So it means, when we have further loop for the outer iteration, so the number of inner iterations required will decrease. Okay, it will decrease. So in other words, with this kind of algorithm, so we can slowly, right, sort non-ordered sequence into an ordered sequence. For example, the original sequence will be what? 67, 98, 45, 23, 88. But after all the outer iterations, so the inner iterations will be 23, 45, 67, 88, and 98. Okay, so this is a very basic sorting algorithm. Okay, so you can see that I have spent a lot of time on this algorithm. Why? Because I want to show you in the future when you try to deal with algorithms, learn algorithms, or debug your algorithms for data analytics. So how to work on that? Okay, so you need to be very clear about every single step in the algorithm you have built or you're working on. So you try to run the algorithms by yourself, okay? On the other hand, you can run the algorithms in C# or in other programming languages step by step. So you compare the results from your results and the results from the computer. If the two results are the same, they are consistent. So it's fair to say that, so the code, right? The code you have up until now, it is correct. At least that part is correct. If you see some mismatch or you see some inconsistency, so it implies something wrong here. Basically, it tells you, right? It gives you a flag that there is some problem there. So stop and check what's going on. So that is how you find logical errors. Okay, logic errors. So because for logic errors, there is no way, usually there is no way for you to what? To observe by yourself. You just read the code. Try to read. It is difficult to find errors in this way. However, so by debugging the code, by running the code by yourself, you can find where is the problem. Okay? You can find where is the problem. Okay? Also, so in the future, you will learn a lot of different algorithms, okay, in different classes. If you want to build a career in data analytics or business analytics. So for this, in these classes, you will learn some algorithms, okay? You see in each chapter, there will be one or multiple algorithms, okay, multiple algorithms. Especially, you want to take advanced graduate level course in data analytics, okay? There will be a bunch of different algorithms. If you are new to algorithm, I can tell you, it will be very difficult for you to just read your book, just read it and try to learn how the algorithm works. It is very difficult, to be honest. So the best way to learn the algorithm is to have a simple example, which most textbook will give you. Will give you an example, okay? Then with that simple example, you try to run the algorithm by yourself, step by step, okay? Assume you are a computer, okay? You are C#, okay? And you try to learn the algorithm in the textbook, okay? So in this case, you will plug in the simple example in the algorithm and run it step by step, okay? After finish all the detailed steps, so most of the time, I'm not saying 100%, 95% or 99%, you will have a much better understanding about the algorithm, okay? If you just try to read the code, because in the book, sometimes it will give you some code, sometimes some pseudocode. So if you have some code experience, so pseudocode means, so it is something between actual code and flowchart, okay? Try to write something in a code format, but with meaningful words or with meaningful equations, okay? Pseudocode. By just reading these things, so if you are not experienced, it will be very difficult for you to learn those algorithms. However, if you follow my strategy, okay, to be honest, sometimes, even now, I still try to learn some algorithm in this way, okay? I follow the example provided in the textbook, and I try to assume I'm a computer, and I run the algorithm by using the simple example. After running the simple example completely with all the detailed steps, you can understand what's going on. You can understand the algorithm, okay? So that's why I show you all these steps, because in the future, you may want to try similar strategy to learn these algorithms, because when you go deep or deeper in business analytics, you will find, oh, so many algorithms are there. Even though I will just try to learn intuitions of each algorithm, and I will try to learn how to use existing packages available on the internet. Still, you have to understand the inner structure or logic structure of the algorithm, okay? In order to learn this, you have to do this, okay? Use simple examples and follow all the steps, 1 step, 2 steps, 3 steps, to learn the algorithm in detail. Then you can move on to next algorithm. So when you finish the whole book, okay, you will say you have learned a lot, okay? You have learned a lot. So to be honest, when you start to learn advanced data analytics courses, okay, when you have a textbook, I can tell you, so most textbooks will have a lot of materials, okay? So you will see the professor will give a textbook with 800 pages, 1,000 pages, 1,200 pages, which is very hard to read in a semester, even in a year, okay, to learn everything. But this is how you read, because the one character in data analytics is there are so many existing algorithms. And in each year, in each month, so many new algorithms will pop up, okay, in different research conferences, in different journals. So it means more and more materials will be accumulated in the textbook, okay, in order to learn all these algorithms, okay. In the beginning, you may want to follow my strategy. You may want to follow, so I want to have one simple example. I want to follow the code provided in the book, and I would like to assume I'm a computer and run the statements step by step, okay? Maybe after 1 or 2 years, or at least 1 or 2 semesters, when you are more experienced, okay? So you can be more efficient. For example, you can read the code in the textbook, then you understand most ideas. That's possible, but in the beginning, it will be very challenging. Okay, that's my why. You can see I spent so much time on details of this algorithm because I want to show you how you should follow, what kind of strategy you should follow when you learn in the future. Okay, because data analytics is a long way to go. Okay, so in order to just finish a master level degree, for example, I want to finish, so requirement of a master degree in data analytics. So you probably need to take 6 to 10 courses in this category, okay? So each course is advanced, okay? And this kind of thing will be in every course you will take, okay? You will take. So that's why I spend so much time on this topic, okay? On this topic, okay? Hopefully you have learned something, okay, from this lecture, because in this whole semester, okay, this part, this subsection is the only place, okay, where we are going to learn some algorithms, very simple algorithms. I want to show you how you should, what kind of strategy to follow in the future, okay, in the future. So this is the sorting algorithm, So let's move on to the next one. So the binary search algorithm. So what is that? So let's still use this example, okay, okay. So let me go back to the very original array, which is cell 67, 98, 45, 23, 88, okay? Now let me ask you, okay, ask us to find, so let's find where is the element 88, okay? So, or we can ask 2 questions. First, so does the number 88 exist in the sequence? The second question is, what is its index number? If the answer is yes, okay? 2 questions. So one simple strategy we have learned, right? Which is, so the basic algorithm, which is sequential search, right? So basically we are going to search. We learned last week. So for sequential search, so our target is to find 88, okay? So we are going to do 67 first, then 98, secondly, no, yeah. 67, not 88, 98, not 88, 45, not 88, 23, not 88, right? When we reach to the last element, 88, we got an answer yes, okay? We find 88, and its index number will be number 4, okay? Number 4 will be the 5th element, okay? In this sequence, the 5th element is the last element, okay? It is the last element, okay? Last element. It means, in this example, if we want to use the sequential search to find what? To find number 88, we have to scan all the elements, right? We have to scan all the elements in the sequence, okay, in the sequence. Now you may ask, why we would like to find number 88? How about number 67? Yes, you're right. If we would like to find where is number 67, so we are lucky. Why? Because the first element is 67. Why, right? When we search the first element, we find it. Okay, there is only one scan. That's it. Okay, which is easy. However, in practice, you have no idea which element will be the target element. Okay, which element will be the target element. So intuitively, You see, for the sequential search, right? For 67, we just need one scan. That's it. For number 88, we need to scan all the elements, which is 5 different numbers, okay? We need to start from the first element until we reach to the last element. 1, 2, 3, 4, 5 different scans, which is bad because you see, we always prefer fast algorithm. You may argue that 5 and 1, the two numbers are not quite different. Computers are fast, okay? So searching one element or searching 5 elements are not making too much difference. But the problem is in practice. For example, let's assume you have 1 gigabyte or 10 gigabyte data on your hard drive. You would like to do some search, okay? Then the difference is there. If you just need to search for the first element, it's easy. But if the targeting element is the last element, so you need to wait for a long time to get the result, okay? To get the result. So intuitively, so we would like to get one algorithm, okay? One algorithm. So which can give us acceptable or good performance, computational performance, okay? For the worst case. For example, even though so the element is 88, so the searching can still give us satisfactory performance. So that is the algorithm. So we are going to learn, which is what? Which is binary search. Binary search. So what is binary search? Okay, binary search. So the binary search is a clever algorithm that is much more efficient than the sequential search, okay? So this is pseudocode. You can see what is pseudocode. Pseudocode means the format, okay? The format of it is like actual code. But if you read each line of a statement, you will see, no, it is not actual computer code, not C# code. It is some meaningful short statement or sentences, okay? Intuitively, pseudocode is something between flowchart, completely intuitive, and actual computer code, okay? It is something in between, okay? It is something in between. So what is binary search? So, and first, for binary search, we assume that the sequence has been what? Been ordered. Okay, the sequence has been ordered. Okay, the sequence has been ordered. So then we would like to search the element from the ordered sequence. Okay, from the ordered sequence. Okay, from the ordered sequence. So what we want to do is, okay, you see that this is the actual code. Okay, now we can read the actual code because the font is larger. Okay, so you see first we have two numbers. The first one is first, and the second one is last. We also have a middle and a position. Okay, we found is false. So found is first, the condition for the while loop is first is less or equal than the last. Middle is first plus last divided by 2, okay? So if the middle equals value, found is true, position is middle. Else if array middle is a greater value, last is equals middle equals -1, first equals middle plus 1. What is that? Okay, we can still follow the same strategy, okay? So so for the previous sorting algorithm, I provided all the details. Now I still try to do the same thing, try to provide all the details, okay? So let's assume that we have an ordered sequence, okay? You have applied ordering algorithm to order sequence, which is 23, 45, 67, 88, and 98, okay? So let's assume, right? Our question is, so we would like to verify if number 98 is in the array, okay? If the answer is yes, okay, where is it? Okay, basically it means, so what is the index number? Okay, what is the index number? So this is the question we would like to answer. So if, let's assume we follow sequential search algorithm. So if we follow sequential search, we would like to do 23 first, then 45, then 67, then 88, finally 98, right? So we need what? So if we use sequential search, right? We need 5, let's use iterations, okay? Iterations. Because we need to scan all the elements in the array, okay? We need 5 iterations. Now let's follow the code given in the slides, okay? Follow the code given in the slides. So let's see how it works. Okay, let's see how it works, okay? How it works. So, and how many iterations do we need? Okay, that's what we are interested in, okay? That's what we are interested in. Because why? Because efficient algorithms are always preferred. Nobody will afford one algorithm which need days, hours, even weeks to run. Because so if the data set too huge, right, you need some solution to run it fast, maybe a couple of hours. But if an algorithm needs weeks to run, then nobody can wait for that. Okay, nobody can wait for that. So let's follow. So let's use the binary search algorithm. Okay, algorithm. So we use code here. Okay, let's assume this is the array. Okay, we would like to search, and we like to search element number 98. Okay. So it means in this algorithm, value is 98. We like to sort if the value 98 exists in the array, okay? So we can do that in the beginning. Number first equals 0, right? It is given here, okay? It is given here. First equals 0. So last equals array length minus 1, okay? Last. So array length, it is 5. 5 minus 1, it is 4. Okay, 4. So middle has been declared no value. Okay, middle. So position is minus 1. Okay. So found equals false. Okay, equals false. So these are the variables declared in the beginning. So you can see first is 0, last is 4, right? Intuitively, first is the index of the first element in array 23, right? Last is number 4 is the index number of the last element in the array 98. Intuitively, okay, you can see it's easy, it's obvious. Then we try to analyze this key part, the while loop. Okay, the while loop in the slides. Okay, the while loop. So for the while loop, okay, for the while loop, this is while loop. It means that we will first check if the expression it is true. It is true, we go inside. Otherwise, we will skip. Okay. So now analyze the while loop. Okay, the while loop. So we have first iteration. Okay, first iteration. So for the first iteration, let's first check the condition, okay? So not found, so is not what? Found is false, right? Not false, it is true, right? Not found, not false, it is true. So for the other sub-expression, first is less than or equal to the last. So first, it is 0, right? It is 0. Last, it is 4. So 0 is less or equal. 0 is less or equal than 4, right? So that expression, obviously, it is true. Okay. So we have true and true, right? For this while loop, okay? Then we do what? Middle equals first plus last divided by 2, okay? So middle equals first plus last divided by 2, right? What is first? So it is 0, last it is 4, right? So 0 plus 4 divided by 2, okay? 4 divided by 2, it is 2, okay? Middle, it is 2. Basically, if we consider middle as an index number, middle will be the third element, 67, okay? 67. So we would like to say if I array middle equals value, okay? So if expression, if, right? I array middle, which is 2. 2 is the third element, 67. So we want to check if 67 equals the target value. The target value is in the research question. In the question we have asked is 98, right? 98. So we would like to see if 67 equals 98, okay? Obviously, the answer is no, right? So false, okay? So condition is false. So we will not do this if part, right? So we do else part, okay? We go else, okay? Else. So else if. So else if condition is if I array middle is greater than the value. So it is, we would like to check if. So the second element, the third element, 67 is greater than 98, okay? So the answer is no, right? Always no. So it is also false. So it's false either, right? False either. So it means we will not do this else if part. We will go to the last, right? The last else, because the first condition is false. The second condition is also false. We will go there, okay? So what is that? It is first equals middle plus 1, okay? Middle is 2, first is 1, so, sorry, middle plus 1, 1, 2 plus 1, it is 3, right? It is 3. So now we are done with the first iteration of the while loop. So we have first equals 3, last equals what? We have got last equals 4, okay? Last equals 4, okay? It means after the first while iteration, we can have, right? First equals 3, last equals 4, okay? This is based on our analysis. So we just use one iteration, that is the result, okay? So let's go back to the while loop, okay? The while loop. So for the while loop, in order to start the second iteration, we need to check this expression first, okay? So not found, okay? Not found, it is still not false. Okay, not false, it is true, okay? The first sub-expression is still true. How about the second one? First is less or equal than last, okay? First, we have summarized when we finish first iteration. First is 3, last is 4. 3 divide 3 less than 4, or less or equal than 4. So it always is true, right? It is true. So we have second, right? While iteration. So for the second while iteration, so we still have middle equals first, right? We have middle equals, right? First plus last divided by 2, okay? So first is 3 plus 4 divided by 2, right? So 3 plus 4, 7 divided by 2 is 3.5 because first, last, middle, all three variables are int. Remember, for int variables, one will do division, right? All fractional part will be truncated, right? Will be truncated. So in this case, middle equals 3, right? Because 0.5 part will be truncated. Okay, we have learned this before. Okay, 3 plus 4 divided by 2, 3.5. The 0.5 part will be truncated. Okay, so now it is 3, which is the value of the int variable middle. Okay, middle. Then we go to the if part. Okay, if. So we would like to check this. Okay, if I array it now, it is 3, right? It is 3. So 3, it is what? It is the fourth element, 88, right? 88 equals 98. No, false. Okay. Similarly, we go else. Okay, we go else. Else, if I array number 3, which is 88, is greater than 98, no, still false. So we move on to the last element, right? First equals middle plus 1, right? First equals middle plus 1. It is 3 plus 1. It is 4, right? It is 4. So we can have after the second, right? While iteration, we can have first equals 4, last equals 4. Okay, we have first equals 4, last equals 4. So we go to the condition of the while loop again to check if we need a third iteration. Okay, so not found is not false, it's still true. First is less or equal than last. So 4 is less or equal than 4. It is still true. Okay, it is still true. So we go inside, right? We go inside. Okay, middle. So we have middle equals first plus last. Okay, first plus last. So it is 4 plus 4. Now first is 4, last is 4, 2, right? 4 plus 4 divided by 2. We got 4, right? Then we'll go to if, right? If. So we go to if, we have if array middle, which is number 4. Number 4 is the last element, the fifth element in the array. So 98, right? Equals 98. Now this time we got yes, right? So yes means so the expression is true, right? It means this expression, it is true, right? In the third while iteration, right? Okay, third while iteration. So it is true. So in this case, we don't need to do else. We don't need to last else. Because the expression here is true, right? We are done, right? When we find it, right? We got what? We got found equals true because now we are inside this if structure, right? Now we got position equals middle it is 4, right? You see, in the third iteration, we have what? We have found equals true, position equals middle equals 4, right? We found the target element 98, and we got its index number 9, which is number 4, right? You see, in the analysis, we can observe, right? With the binary search code, even though the element is the last element, right? So the target element 98 is in the last spot in the array. So in total, we only need 1, 2, 3 iterations. Okay, we only need 3 outer iterations. But for the sequential search, right, we need 1, 2, 3, 4, 5. 5 different iterations to get to the element 98. Okay, 98. So in the new binary search algorithm, so we can see that we only need what? 3 different iterations. And intuitively, right, each time we would like to cut off, right? For example, in the beginning, right? So in the very beginning, first is 23, last is 98. Our scope is all 5 elements, right? When we finish first iteration, we got first is number 2, which is 67. Last is 98, which is only the last 3 different elements in the array. So in the second iteration, we got first is now 88, last is 98. We have 2 elements remaining. In the third iteration, we got 98. Okay, you see intuitively, right? In each iteration, we will cut off half of the sequence, right? We will cut off half of the array, right? So it means for the half of array, we don't need to search. We are going to focus on the other half of the array. So it means, so in each iteration, we can make sure we can get rid of half of the remaining elements, and we focus on the remaining half, right? So that is why the name is binary search. Okay, binary search. Okay, so you see that I try to show you all the details of this binary search algorithm because this is another example for me to tell you, to teach you in the future how you can learn this algorithm by yourself. Okay, by yourself. Learn this all other advanced algorithm by yourself. Okay, by yourself. Okay. So now we are done with subsection 7.6. You can see we have a bunch of algorithms. The algorithms are challenging. They're challenging. Okay. So hopefully, all the time I have spent can be useful for you. You can learn how you can learn in the future because there's no way I can teach you, right? Or a lot of algorithms in the course. You can see only for these simple algorithms, we spend a lot of time on those algorithms. So in the future, if you take other data analytics courses, you will learn more and more algorithms. Okay, more and more algorithms. So the strategy I follow here will be a useful strategy for you to follow to learn those advanced algorithms. Okay, advanced algorithms. So hopefully, all the time I spent here can be useful for you. Okay, can be useful for you. So now let's continue with the materials we have in this chapter. Okay. So 7.7, 2-dimensional arrays. So previously, we focused on 1-dimensional array. Now we can also deal with 2-dimensional, okay? A 2-dimensional array is like several identical arrays put together. You can see that you have one row is an array, another row is a second array, the third row is an array, right? But we can put them together. So it can hold multiple sets of data. So it can be illustrated by a table with rows and columns, okay, rows and columns. Actually, it is very similar as the worksheet, right, the Excel worksheet. So rows and columns are numbered 0, 1, 2. Similarly, so row index number will start from number 0. Column index number will also start from number 0. For example, the very first element in the corner here. So the row index is 0. The column index is also 0. 0, 0, not 1, 1. Okay, not 1, 1. So this is how we declare a 2-dimensional array. A 2D array requires 2 size declarators. The first for the number of rows, the second for the number of columns. We have double scores equals new double 3 and 4. This indicates that the scores variable references a 2D array with 3 rows. Okay, the first one is how many rows are there. The second number will be how many columns are there. 3 rows and 4 columns. So you can also declare constant, right? For constant, every letter has to be capital. Constant 3 and 4, and declare rows and columns. Okay, this is how you declare a 2D array. So how you access a 2D array? You need 2 index numbers. Okay, 2 index numbers. The first element, it is 0, 0. The second element in the first row will be 0, 1. The third element in the first row will be 0, 2. The second element in the second row will be 1, 1. Okay, you need to remember. Okay, in C#, So for arrays, no matter it is one-dimensional or two-dimensional, the index number will start from number 0, okay? Number 0. So we can assign values to array elements. So in this case, if you would like to assign 71 to the first element, you got scores 0, 0 equals 71. If you would like to assign this element, which is row number 1, column number 2, right? So, no, row number 2, right? Second row and the third column. Let me use second row and third column. So with the value 90, you will got it is index row number 1, index column number 2. Okay, it is scores 1, 2 equals 90. Okay, so this is how you assign values to a 2D array. Okay, so it is the concept is very similar as one-dimensional array. However, you have to be very clear about for both rows and columns, the index numbers will start from number 0. Okay, number 0. Okay. So also to implicit size and initialization of 2D array, we can use. So there are no dimension. Okay, dimension numbers, but we provide all the elements right in the declaration. So you have a very outer, right? A very outer pair of curly braces. Okay, very outer. Inside this outer pair of curly braces, you have a bunch of inner pair of curly braces. In the first one, you have 71, 67, 45, 8, 82. In the second pair of curly braces, you have 45, 87, 90, and 68. In the third pair of curly braces, you have 80, 75, 39, 61. Okay. So basically, in each inner pair of curly braces, we are declaring a row. You see 71, 67, 45, 82. This is row number 0, right? Row number 0. It is the first row, basically. 54, 87, 90, 68. It is row number 1, second row. 80, 75, 39, 61. It is the third row, row number 2, okay? You see in each inner pair of curly braces, we provide all the elements in that row, okay? In this example, we have 3 different rows. That's why we have 3 different pair of curly braces in this example, okay? In this example, we have 3 pair of curly braces. It implies we have 3 rows. In each pair of curly braces, we have what? We have 4 elements. It means there are 4 columns in the 2D array. Okay, C# can find this implicit piece of information from this statement. You do not need to provide the actual number of rows and columns. Instead, you provide all the elements, right, in the 2D array. Okay. So using nested loop with 2D arrays, okay? So here we have rows is 3, column is 4, right? We declare 2D array. And in this case, so you have nested loops. You can see we have out loop, row for row loop. For each row, we have an inner loop to enumerate all the columns. It's the strategy like this, right? First, for the out loop, we fix the first row. For the inner loop, we are going to do column 0, column 1, column 2, column 3, right? Then for the second outer loop, row number 1, we do column 0, column 1, column 2, column 3. For the third outer loop, row number 2, we are going to do column 0, column 1, column 2, column 3, right? This is so nested loop to access or to assign values to 2D arrays or 2D arrays, okay? So also, this is another example, right, for 2D arrays. So we can use the 2D array for the list box item add, right? Score to string, right? So basically, we like to have all the scores added in the list box, okay? List box. So here is one example. So declare a two-dimensional int array. So with 4 rows and 5 columns. For each element in the array, assign its value to be the sum of its row and column indices. For example, for the first element, since it is in the first row and first column, the value should be 1 plus 1 equals 2, okay? We want first element 2. So the second element in the first row 1 plus 2, which is 3, right? The third element in the first row, it is 1 plus 3, which is 4, right? So in this case, we can do what? First, declare two constant, rows 3, columns 4. Then we declare an int array with 3 rows and 4 elements. We use the nested loop to set, right? So array row columns is row plus 1, column plus 1. Why? Because both row index and column index, both index numbers will start from 0. Okay? For the first element, we need to get 2, right? But index is 0 and 0. So we need 0 plus 1 and another 0 plus 1, okay? Which is number 2, okay? So this is one example. So another topic we need to deal with is jagged arrays. So a jagged arrays is a special type of 2D arrays. So it means rows in a jagged array can have different length. In the previous one, right, you can see that in a two-dimensional array, this one, all the rows have each row has 4 elements. Number 4 is the same for all rows, but in jagged array, that number can be different. For example, you can declare a jagged array with 4 rows. For the first row, it is 1, 2, 3, 4. Second row, 5, 6, 7, 3 elements. Last row, 8, 9, 10, 11, 12, 5 elements, right? 5 columns. So the resulting array will be this. You can see each row has different length of elements. So this is jagged array. So in this case, you can also access element by using the index number. Still, for a jagged array, all index numbers for both rows and columns will start from number 0. To assign a value to row 0, column 3, you need 0, 3 equals 99, okay? You need to use index number. So here is one example. Define a jagged int array with 3 rows. The first row is 3, 9, 6, 9. The second row is 4, 5, 6, 7. The third row is 12, 5, 8, 10, 3. The reference name of the jagged array is numbers array. After the declaration, assign value 7 to the third element in the third row. So in this case, you just need to revise the example we learned here, right? We need first declare array with 3 rows. The first row, 3, 6, 9. Second row, 4, 5, 6, 7. The fourth row, the third row will be 12, 5, 8, 10, 3, right? So, and assign, value 7 to the third element in the third row. So third row, index number 2. Third column, index number 2. 2 equals 7, okay? Equals 7, okay? So this is the example. So we can use nested loops to process jagged array. So in this case, because each row has different length, okay? Each row has different length. The number of columns are different for different rows, okay? That is why, so we can do this. We do this row jar array length. We'll give you the row number. Then we give the row index. Jar array row, give the row index. When you use the length property, so it will give us the column number for that specific row, okay? Because in this case, so the row numbers, numbers of rows are different for different rows. A number of columns are different for different rows. That is why, so we need to use the length property to access the element in a jagged array with a nested loop. Okay. So this topic is a list collection. The C# list is a class in the .NET framework that is similar as to array with the following advantages. A list object does not require size declaration. Its size is automatically adjusted. You can add or remove items. Syntax to create a list is this: list data type, list name, new list data type. Okay. For example, list string names new list string. You declare a list of strings. List int numbers equals new list int. List of integers. Okay, we have list of integers. So this is how we add or remove list items. So this method are embedded in C#. You can use it without building it by yourself. Okay, we can use name list. We first declare a list. You can do list add method. We can add Chris in the list, add Bill in the list. Okay. So to insert an array, insert a list, use insert method to insert an item at a specific index. For example, we'll want this name to be inserted, right, in index number 0. Okay, add means the name will be added in the bottom of the list. Insert means the target string will be inserted to our target index number. To remove items, we use remove method. So we can do name list or remove Bill. We can remove Bill from the name list. Okay. So remove at method, we can remove an item at a specific index at a list. For example, here we can remove the name index number 0. Basically, it is the first element in the list. Okay. You can have add, insert, remove, and remove at. Okay. Remove at, different methods. So initializing a list implicitly, to initialize a list implicitly, so we simply define its items when you declare it. For example, we do 1, 2, 3. There are 3 elements for int numbers. For string name list, we have Jim, Bo, Sue, 3 names for the string list. Okay. The count property holds the number of items stored in the list. Okay. For example, we do name list less than count. So that will be similar as the length property of an array. Okay. For a list, so the corresponding property will be count. Okay, will be count. So this is some remarks. For list collection, you need to know how to declare a list object, how to insert a new item in the list, how to remove item from the list. Okay, so you see that we spent almost this whole lecture on this chapter because it's difficult. Okay, because it is difficult. I hope all of you can learn something, especially how you are going to learn advanced algorithms in the future. Okay, because this is the only chance for us in this semester to learn some algorithms. Okay, I try to teach you how you should learn in the future. Hopefully it is helpful.